When you're creating an application, you're going to have some instances where you're going to get external data into your app. For example, you may be fetching some data from a different server, and the data that you get back may not be of the shape that you expect it to be, and that can cause bugs in your app. And fetching data is just one example, but there are about 10 instances where you want to be extra vigilant when it comes to getting external data into your app, because the data that you get may not be of the shape that you expect it to be. So in this video, we'll talk about what those 10 places are, and I'll also show you why TypeScript alone isn't enough, and you probably want to use a schema validator like Zod. So let's think about what we're doing when we're creating a full stack application. So let's think about validating external sources of data. And in this video, I'm going to focus on React and Next.js, but it will work the same in other technologies as well. All right, so let's say we're creating a full stack Next.js application. We're going to have a front end part, right? So we're going to have front end, and I'm actually never sure how to spell this. Is this 2 words or is this just 1 word? Let's assume it's 1 word. And we're also going to have a backend portion. So here we'll have backend. All right, so let's start with the front end here. So where does a front end typically get external data from? Well, very typically the front end may fetch some data from the backend, right? From our own backend. So here the backend may send some data to our front end. So from the perspective of the front end, there's external data coming into the app. So let me describe this a little bit. By the way, this cool tool I'm using is called eraser.io. They are the sponsor of this video. So the front end will make an API request to get data from the backend. And let me make this a little bit smaller. Right, so from the perspective of the front end, we're going to receive some external data from making API requests to our backend. If we're creating an e-commerce website or application, we may want to fetch product data from our own backend, for example. But we can also get data from third-party APIs. Maybe we want to customize the website based on the user's location, and maybe we use a third-party API for that. So we could also receive external data from third-party APIs. And the data that we're going to get from a third-party API may not be of the shape that we expect it to be. And TypeScript alone will not protect us against that. So we may want to use something like Zod to validate that the data that we get back from these API requests is actually of the shape that we expect it to be. And we'll look at that in a second, but let's just finish this diagram here. So where else is our front end going to get external data from? Well, probably also from the user itself, right? So the user can fill out a form. So that's another source of external data, right? Form data. And let's see, where else on the front end are we going to get external data from? Well, we could also have local storage, right? So we do not manage local storage ourselves. The browser manages that. And there's also session storage and other storage, but for simplicity here, we'll just focus on local storage. We may store something in local storage and then later we want to grab it out of local storage again, but we don't know for sure what we're getting back from that local storage. It's an external source of data. And before we deal with whatever we get back from local storage, we may want to validate that it actually has the shape of the data that we expect it to have. All right, so we have 4 now. There's one more that's also a major source of external data, and that's actually the URL. Right, so maybe you've seen my other video about storing data in the URL, for example, search parameters, right? So if we have a URL like this, domain.com, and we may store some data in here, maybe an ID, maybe a color parameter, and later we may read this data back into our application. But the URL is also an external source. We do not manage the URL ourselves. The browser does that, right? The user could be changing things in here. So when we read data from the URL, we may want to validate that what we get in our application is actually the shape that we expect it to be, because if it's a different shape, it may cause issues. And it's not only search parameters, could also be path parameters, but these are the 5 major sources of external data that your front end is going to receive. And because they are external sources, there is less certainty that the data that we get from those sources is of the shape that we expect it to be. And TypeScript alone does not help us out against that. And I'll show you an example of why TypeScript alone is not enough. So we want to validate that what we get back from these sources is actually the shape we expect it to be. So that's why people use schema validators. In this video, we'll use Zod, but there is also Yup. And they all have the same purpose, validating that the data is actually the shape that we expected or want it to be. All right, now before we continue with the backend, let's actually take a look and see how this would work on the front end. So let's go over each one here and see why TypeScript alone is not enough and why we need a schema validator like Zod to validate the incoming data. So let's start here with the most common ones. That's actually going to be API requests. So you're going to make API requests to your own backend. And this will be very similar as with third-party APIs. On the left side now I have a simple product component, and this will fetch some data from our own backend. And let me make this a little bit more compact. I will also put this one here and the URL here as well. All right, so let's go over each one. So we make an API request. request. Now, I'm using Next.js here. These days we have client and server components, and maybe you've learned that you can fetch data in server components, and that's totally true, but there are still cases where you want to fetch data from the client. And just as a simple example, you could do that with useEffect, right? You've probably already done that in the past, right? So with useEffect here, we can fetch data, right? So what we could do here is fetch. Let's say we make an API request to our own backend, right? So to this route. Now in Next.js, it's very easy to quickly spin up your own backend route. So here I just created an API folder, and then you can create a route.ts file. And what this function will do is just return a product to our front end. So here we have a product object. It has a name that's a string and a price that's a number. And that's what we're going to send back. Right, so the backend here in this example will send data to our front end. So that's what we're going to receive here on the front end. At least that's what we would expect. Right, so here when we fetch then, we will eventually get a response. The response will be in JSON format. So we're going to convert it from JSON format to a normal JavaScript format. And then here we get the actual data. We can call that data or product. And then here we can do something with that product. For example, we may want to log the name of the product. So we could say product.name, and maybe we want to uppercase the product name. So on a string, you can call to uppercase, right? So this is a method that's only available on a string. Now, when we do this, we don't get any warning from TypeScript because by default, TypeScript types this return value from APIs as any, and any means anything goes. So basically no type safety. And why is that a problem? Because we know it's going to be a name as a string, right? And since we know it's going to be a string, we should be able to call to uppercase. So if I save here and I go to my application here, I already opened this up. Now if I reload the page, we should see something in console log. We see cool jeans. So there's no issue here. This is all working perfectly fine. Now in the real world, you may have different front end and back end teams, or you yourself may be changing things on the back end. The point being is on the back end, you could be changing the shape of the data, or maybe somebody else that's also working on this project may change the shape of this product data. So instead of having a name, maybe this gets changed to having an ID, let's say. So now we have no name in the product. So if I save here now, and now here when we try fetching this data and accessing to uppercase, we will run into major issues, right? So here our application is crashing now because we are trying to access to uppercase on name, but name does not exist on our product object, right? It existed before, but for whatever reason, and this happens sometimes in the real world, the shape of the data was changed, and now we have an ID and not a name. And TypeScript here did not warn us about this. And you could say, oh, well, that's because this is an any type. Maybe we should type this as a product, right? Maybe you've learned, don't have any's in your code base. We should actually type this as something else. So maybe we want to type this as a product, but this doesn't solve the issue because if we have type product here, we could say, well, this is going to be an object with a name and a price. That's going to be a number, right? Because that's what we had before. Here we had a name that's a string, right? And a price that's a number. So you could say, well, okay, so this product here that we're going to get back from the back end, that's going to be of this shape. If we indeed return an object like that, here when I reload, we don't get any errors. We still log it to the console. But again, in the real world, the back end may get changed over time. So instead of sending back a name, we may be sending back an ID, and actually an ID is probably going to be a number. So maybe we are removing this name property and instead we're going to be returning an ID. So now if I save here, even though here on the front end we have typed this as product, if we now refresh, you can see we get an error. Our application will crash in practice, even though we have typed this with TypeScript, right? So TypeScript alone does not help us out here because TypeScript doesn't exist during runtime. It doesn't actually check what's going to be in this variable here because this all gets compiled into normal JavaScript, right? So here I'm working in a TSX file. This is TypeScript. It will be compiled and it's continuously being compiled to normal JavaScript, and then the application gets run, right? After compilation, TypeScript does not exist anymore. It doesn't actually look into the variable to see what's there during runtime, right? So TypeScript is helpful more for when we are actively developing here, where it's doing some static checks, but it doesn't help us out during runtime when the actual data is being received from the backend. And here we are fetching data from a backend, but it works the exact same when we are fetching data from a third-party API, right? So you can type this with TypeScript all you want, but during runtime, in reality, you don't know exactly what the shape of this data is going to be. And because of that, you may accidentally crash your application, and that can be very damaging in practice. So that's not what we want to do. We want to build robust web apps that don't crash when they're getting some external data. Now you could say we can solve this very easily with optional chaining. So if we do this, if I now now reload, you can see we don't get any error. And this will indeed stop our application from crashing in case the name property isn't here. But what if the entire product isn't there? What if we actually don't return anything? And then we try to access .name on product. The product is empty, let's say. So then also here, you need to not forget to also have optional chaining here. And this will only prevent our application from crashing. But what if we want to output a nice error message to the user? This does not help us with that. And it's also just messy code. Another problem with optional chaining is it doesn't really protect you from when the value actually does exist, but it's of a different shape. So here we may want to log the price, let's say, but we only want to see the last 2 decimals. So if there are more decimals, we just want to cut it off at the second one, right? So this toFixed is a method that we can use on number types, not on other types. So when we return this price and it's a number, if we now refresh here, you will see we don't get any errors. This will work, and we get undefined because we're not returning a name, but we don't get any crashes. So okay, that's better. But what if this is actually a different type? So it actually exists, the price exists, but it's using a method that does not exist on a string, right? So toFixed is a method you can use on a number type. Even though we have used optional chaining here, we now have crashed our application once more. So to fix this, you could go down the road of checking that the type of the product price is a number, right? Type of product price is number, and then you can try to use this, right? So you could go down this route, but you can already sense that this is very messy code. There's no logic or system in it, and therefore this is not a robust solution for double checking that the data that we get here is actually of the shape that we expect it to be. So this is where a schema validator comes into place. And a popular one now is called Zod, but there are other ones as well like Yup, and they all have a similar function, which is to simply validate the data. So whenever we have an external source of data, whether it's from the backend or a third-party API, we may want to use Zod. So let's take a look at how we can implement Zod here to verify that the product that we get here is actually of the shape that we expect it to be. So I'm gonna install Zod here, npm install Zod. And this is a runtime dependency, right? So this is not a dev dependency. We will actually use this during runtime. So I'm gonna close here, and then here we can use Zod to validate the product. So the way Zod works is you specify a so-called schema, which is basically your expectation or how you want the data to be. So let's say we expect this data to be an object. So we say z.object, and in that object, we expect there to be a name and also a price. And the name needs to be a string and the price needs to be a number. And you can be more specific than that with Zod. You can say it should be negative, positive number. Let's keep it a little bit simple here. It should just be a number. Let me import z from Zod. And now we can run whatever we get back here through that schema essentially, and Zod will tell us if it's the correct shape or not. So we can say product schema.parse, and then we pass in that product. You use this variable, the schema that we just created, the expectation of what we expect the shape to be, and you can call .parse on that and pass in whatever you want to check according to that schema. Now, if this, whatever we pass in here, does not adhere to that schema, so it turns out to be not the shape that we expect it to be, with the parse method, it will throw an error. We can wrap that in a try-catch, and we can catch the error that way, or what people seem to prefer is to use the other method here, which is called saveParse. Here, if this, whatever we pass in, does not adhere to that schema, it will not throw an error, it will just return a result here, and that result will have a success property. So we can check the success property. So if there is no success, we just want to log the error, because Zod will also give us nice error messages, and then we probably want to return here to return out of this function, and otherwise there was a success, so it is actually the shape that we expect it to be, and therefore we can now safely continue with this variable. So after this check of success, it's important that you continue with the variable that was actually checked by Zod, right? So this product variable is unsafe. This one has not been checked yet, but this validated product variable has been checked. So here we can safely use it to, for example, access the name. Now when you parse it with Zod, they will actually put it on a data property. So here if you want to access name, it's .data.name, right? Or price. And we actually get some nice autocomplete here with Zod as well. So we see that we can access name and price. And these are typed properly. So if I try to do toFixed, which is something you can do only on numbers, you can see I get a warning here, right? So this is now properly typed as well, right? So here, if I try to access name, and we don't send name from the backend, right? So here on the backend, we are sending back an ID and price. So name is not on here. So previously we were crashing our application, right? But now if I refresh here, right? So you can see our application doesn't crash, and we should get an error from Zod because Zod will check if name is actually in there. So if I open up our console here, we can indeed see that Zod is warning us here. We get a nice error message here from Zod. So here Zod will let you know which key there was a problem with. So here that's with path. So here the path is going to be the key of this object. So here for name, there was a problem. It expected a string, and what we got back is undefined because we're not returning name here, right? If I do return name here, let's try that. So now we are returning name instead of ID. And let's say this price right now as a string, but we are expecting a number. So let's actually make this a number and see if Zod will parse this properly. So now it's the correct shape, right? So now we do have a string for name and a number for price, which is also what we codified here in this schema. So now we should be able to access this data.name without any errors. So let's try this. I'm going to refresh here. And now if I open up the console, we don't see any errors. And in the console, we indeed see our name here, right? So now this is how we can validate incoming data from our own backend, but also from third-party APIs, right? So if you make a fetch request to a third-party API, it's even less secure because we don't know what the third-party API is going to send back. At least with our own backend here, we still have control over this. Now, this was a little bit of a contrived example just to show you how everything works here and the logic behind it. In practice, if you get external data with TypeScript, you don't just want to type it and assume that it's going to be that shape. So here, the better type would actually be unknown. And then TypeScript will warn you if you try to access something without properly validating it first. And Zod just makes it very easy to validate. And so we wouldn't even type this in TypeScript ourselves, right? So this type product, we wouldn't even have this. So this would be a more realistic example. So now we don't have that product type in TypeScript anymore. But what if you do need that product type? Because it's likely that we're going to work with this product in other instances as well, and we may need that product type. For example, we may have a helper function, get price from product, which takes in a parameter product of type product. And then we just want to return the product.price. Right? So here we want to type the parameter as a product, so we can only pass in a product. So now should we create a separate TypeScript type product, basically just what we did before, and now we are basically duplicating ourselves because now here I'm essentially specifying the same as here, right? So by adding Zod here, it now looks like we're going to have a bunch of duplications. Basically every time we have our own TypeScript type, we're also going to have a Zod schema, which basically describes the same. And the good news is we don't have to do that. We only have to specify it once here with Zod, make Zod the one source of truth, and then if we do need a TypeScript type, for example for a helper function or somewhere else, we can easily infer the type from that Zod schema. So now here we've already defined this here with our schema. So then we can take type of product schema, pass that to z.infer, and that will give us the TypeScript type, right? So here, if I hover this type, you can see this is the same as what we had before, right? So then we can use that in other places as well, and just make sure that our one source of truth, Zod, accurately describes the data. That's also helpful because let's say you change the schema here, maybe it also needs a description. If we would also have a separate type, we would have to manually change that as well to make sure they stay in sync. But now, because we are inferring it here, whenever we make a change here, it will automatically be updated here in the TypeScript type as well, right? So that's really handy. Now in practice, when you are fetching data like this from an external source, usually you're going to use something like React Query to help you out with. So React Query does not do validation like this, right? React Query is for caching and retrying and things like that. So you may want to use Zod in conjunction with something like React Query. And if you're making API requests to your own backend, there is an even more robust solution, which is called tRPC. So if you control your own API routes, you may want to use tRPC, which does something similar under the hood. Now with tRPC, it is a little bit more of a setup, so you really have to buy into that system. So if that's too much, you could just use Zod. And if you don't control the backend with third-party APIs, for example, you cannot use tRPC because you don't control that backend API, right? So here, let me type that here. If we're going to get data from a third-party API, I want to run it through Zod first before we actually work with that in our application. And let me make this medium actually, right? And the same is true for API request to our own backend. Whatever we get back, I want to run it through Zod, or I want to get an even more robust solution with TRPC, which does require a little bit more setup. All right, let's take a look at these other external sources on the front end. So very commonly, we want to get input from the user, right? So we're going to have form data, and that's also external data. For example, we may have a form here, a checkout form, and the user will fill out data here, name and email, their address, city, state, zip code, right? So you have a bunch of different types of data. An email is a string, but it can be even more specific. It's an email string, and a zip code may be a number. Checkbox is on or off. So whatever the user is giving us here, we can run it through Zod, and if there is a problem with the data, we can immediately give feedback to the user so they can fix it. Now in practice, when you work with forms, you want to use a solution like React Hook Form or Formic to manage your forms, because they help out with a lot of issues that you're going to run into with forms. For example, React Hook Form will help you out with form validation, but also with error and loading states and resetting the form, basically form state in general, and also with performance. So it will prevent unnecessary re-renders. So React Hook Form will help you out with validation. So you may say, why do we even need Zod there? Well, because we're going to submit this form data to our backend. From the perspective of the backend, that will actually be incoming data. And we'll look at that in a second. So then when the backend receives that data, it may want to validate that data as well, because you cannot really trust anything coming from the client. And since that's going to be the same validation as here on the front end, it would be nice if we could reuse some schema so we can use it both on the client side as well on the backend. And with React Hook Form, well, that's only on the client side, right? So if we do form validation with React Hook Form, well, that's just going to be here on the client side. We cannot reuse that on the backend. However, if we do form validation with Zod, we can use that schema here both on the client side as well as here on the backend when we get that incoming form data. And I actually did a tutorial on React Hook Form, so check out that video if you're interested in that. But just to give you a quick example from that tutorial, so with React Hook Form, if I scroll down here, we have a form, and we want to use React Hook Form for easily managing form states, so with errors and loading states and resetting states, and also with performance. So we still want to use React Hook Form for those reasons, right? So React Hook Form, I can use the use form hook here. It will give us a way to deal with form state, errors and loading or submitting states, resetting the form, and it will give us that performance. But the form validation, we want to do that with Zod. So here we can connect Zod to React Hook Form with a so-called resolver. So Zod resolver, and then, well, with Zod you always have a schemas, so basically a description of what you expect or want the data to be like. And this example has a sign up schema, right? So with Zod we can then specify what that should look like, so there should be an email. And with Zod we can also be more specific than TypeScript, by the way. So if we have some email field, we can say it should be a string, but we can be even more specific. It should specifically be an email string. And then with password, for example, we can say it should be a string, but also at least 10, right? So you cannot do that with TypeScript. And then here with Zod, we can also have a nice custom error message. So if there is a problem with that, well, we can customize the error message. And with Zod, you can also do more advanced validation. For example, make sure that confirm password and password are the same. So here you have the refine method, which will give you access to all the data from the form in this case. And then you can check if the data.password is strictly equal to the confirm password. And then here you can specify a custom error message. And then we can also infer a TypeScript type from this schema. And why is that beneficial? Well, if we scroll down here, we can also specify a type here for React Hook Form, and we can specify this form is going to be of this type, so with email password confirm password. So then here, when we register this input for React Hook Form and I make a mistake here, TypeScript will help us out here. We get a warning here and we can fix our mistake. And then also when the form gets submitted, here on submit, we get data here and we know that this is going to be of that type. So here we can also specify that type. So then we can easily work with this data because we know what fields are going to be on there. This has been validated through Zod before we actually run this function. And the real benefit is now that when we actually submit this form, right, so from the front end to the back end, from the perspective of the back end, that's external data coming in, right? So actually there should also be an arrow going from the front end to the back end. So it's a two-way street. So the back end will also get data from the front end. And we want to do the same validation on the back end as well. So we could put this schema in our library and then import this on the back end as well. We don't have to duplicate ourselves. We can just have Zod, one source of truth. We can infer TypeScript types as well as use it both on the client and on the back end. which is really nice because now if we change a field in our form, maybe we want to add address. If we just change it here and we import the same schema on the back end, it will stay in sync because we have one source of truth. So our TypeScript type will be in sync, our backend will be in sync, and that's much more robust than if you would do it in a different way. So also when we're getting data from a form, we also want to run it through Zod before we do anything else with it in our application. So let's take a look. What else do we have? We also have local storage, and let's say we have some kind of cart component. We want to store the cart information in local storage. So then if the user comes back, we can quickly grab it from local storage again. So what we can do here is we could say cart. Well, we can do local storage, get an item, and that's going to be in JSON format. So we want to convert it from JSON into a normal JavaScript object. So we do json.parse. It could be that the user cleared their local storage, and therefore this get item here could return null. So if it's null, we could also have an empty array, let's say, or an empty object. All right, so then we have a cart object, at least that's what we expect. So then you may want to do something like console log cart.totalPrice perhaps. Right? Maybe the cart object, you expect that to have some total price property. And here we don't get any warning from TypeScript, because if we hover cart, TypeScript types this as any, which means anything goes. We can do whatever we want with this, right? I can now access anything, even blah blah, let's say, because with any, anything goes. So we could type this a little bit better. So we could say maybe we expect this to be some type cart, but TypeScript does have a better type for when you don't know what the data is actually going to be, and that's the unknown type. And when you type it as unknown, TypeScript will actually warn you when you try to access some property, because here it will say, well, cart may not exist, right? Cart is of type unknown, so you cannot just start accessing total price. So now what we would have to do is the same as what we saw before. So now we have to make sure cart exists. Right? So if cart in here, we can do something with cart, but now we don't know if total price is gonna exist, because it could also be an empty object, and so we could add more checks here and then try to access the stuff that we need, right? So that technically does work. It's not a clean structured way of doing it. So here, whatever we get back from local storage, we also want to run it through Zod, which will make all of this much more ergonomic. And so what we could do here is we could create a cart schema. So we could say cart schema is z.object, and it could also be an array, by the way, right? So maybe we're just storing an array of products. In that case, if the cart is empty, we probably just want to have an empty array, and then this wouldn't be an object. We also have array in Zod. So here I can import z, and then what we can do is in the array we want to have a bunch of objects. So we can say in the array we have z.object, right? So we have an array of objects, and then every object has an ID, so z.number, let's say, and maybe also a quantity. So we could say the quantity is going to be a number, but we can be more specific. So what we can do, what we cannot do with TypeScript, but what we can do with Zod here is we can say it should be an integer, and specifically a positive integer, right? So with Zod you also get more fine-grained control than with just TypeScript. And then we can run this variable through that schema. So we could say validated cart. We're going to parse that cart on to see if it adheres to that schema. If that's not the case, so if there's no success, well, what we want to do probably is remove whatever was in that local storage because it's outdated, right? So realistically, this could happen if, for example, the cart that you stored in local storage, maybe they were still storing data from a long time ago. And meanwhile, your app has updated to have a different shape of cart, right? So here, when you grab the cart from local storage, it may still be a different shape, an outdated shape. So if that's the case, we may as well just remove it from local storage, and then whatever we want to do here, right, return. And if the cart is of that shape, so if success is true, we can now continue safely, knowing that validated cart here, this variable, right, so not this one, we need to use this one, will now have a data property on here from Zod, which will then have this shape. Right, so the schema. So you can see here, I get a suggestion here to map, and I can use map here because we have validated that it is indeed an array, and map is a method on arrays only, and I don't get any warning here because it's already validated. Whatever you get back from local storage, run it through Zod, and then you can work with it in your app. And let's quickly take a look at the last example here for the front end. So sometimes we want to store our data in the URL. This has many benefits. I highly recommend you check out my other video on this. And once it's in the URL, we want to get it into our app. So we want to read from the URL. So we're going to get data from the URL into our app. So here in Next.js, we can use the use search params hook, and that will give us search params. And for the same reasons as before, we don't know what exactly is going to be in here. We may have some idea, but we want to be sure. We want to validate before we continue working with this. So we can quickly create a schema here with Zod, just called search params schema. And that's going to be an object. And in there, we may expect an ID, right? So here we would expect an ID from the URL. So we could say z.number. I will import Zod. Now, one other cool thing in Zod is that you can also coerce this to be a number. Because if we read something from the URL, right? So if I would add ID is 5 here. If we now read that, what we get back is actually a string type because everything in the URL is going to be a string. But we may want to work with this ID as a number. So we can immediately, when we run it through Zod, we can immediately transform that into a number. We can make sure that it's going to be a number. If it's already a number, well, it will stay a number. But if it's a string, Zod will coerce this into a number, right? That's not a powerful feature of Zod. And maybe we expect a color as well in there. This is just going to be any string, but we can also be more specific than that with Zod. So we can say it's an enum and it can only be red, green, and blue, right? So then whatever we get back here, we can run that through Zod again. Now here what we get is actually not just an object. So here we do need to convert that into an object first. So search params object. So that would be object dot from entries search params, and then we can run it through Zod, right? So whatever we get back from the URL, we want to run it through Zod, and then we can do something if there's no success, right? So if there's no success, we want to do something, and otherwise we can safely assume that this data property on here, right? So beginners always make this mistake. You should not continue with this object. This is pre-validation, right? So this is not safe. It's what Zod returns here will actually be safe. It will have a data property with the validated data on there. So then here we could be sure that we get an ID and that it's also a number. On a number, you can do to fixed. Right, so here this works. We don't even get a warning here because this will also be properly typed. Right, so here I also get autocomplete, so I get ID and color. Right, so this is another reason for using Zod. Alright, so these were the major sources of external data on the front end. Now let's take a look at the back end. So let's continue with a Next.js example. So in Next.js, if you're creating a full stack application, you can also very easily add back end functionalities. So we do that with these API route handlers. So we have these API route handlers. But these days, we also have server actions and we also have server components. So these are React components that only run on the server. So let's think about where this backend will get external data from. Well, we already saw that here when we submit something from the front end to the backend. From the perspective of the backend, that's incoming data. And generally speaking, you cannot trust anything coming from the client. So here, when we receive data from the front end, we want to run it through Zod, or a more robust setup even is TRPC, right? So form data, for example, we're going to get that here on the front end and we run it through Zod. And if during parsing there is an issue with the form data, we can immediately give feedback to the user so they can fix it. And if everything is good, we will gladly accept it into our front-end application and probably eventually submit it to our server. And then here on the server side, when we receive that data, we're going to parse it again. And with Zod, you can reuse these schemas. So you only have to create it once and you can use it on both the client side as well on the server side. And if it validates again, we can very safely work with that here on the backend. Now, typically when you submit form data, for example, in Next.js, you're going to work with that in these API route handlers or in server actions, right? So you don't submit something directly to server components. And I have a complete React and Next.js course, so check out the links in the description. But there are other sources of external data for the backend as well. For example, the backend may also make third-party API requests themselves, right? So the backend can also make third-party API requests. And let me make this a little bit bigger, not that big, right? So when the backend gets data from the third-party API, whatever we get back, we may have some idea what it's going to be, but we don't know for sure. So we want to run it through Zod first. We cannot use TRPC because we don't control the backend of that third-party API. And let me make this a little bit bigger. And another source for external data for a backend is webhooks. So if you're working with payments, for example, if somebody successfully completes a payment with Stripe, let's say, Stripe will send you a message. They will let you know that somebody successfully completed a payment, and they will include data in there. So they may include data of who paid and how much they paid for which product. And so before we actually work with that data, you can already guess it, we're going to run it through Zod first, right? So these are all network requests. So we get a network request from the front front end, third-party APIs, as well as webhooks, but there are other sources of data for a backend as well. For example, you may be loading environment variables into your app, right? So I will say environment variables. And there are actually many things that can go wrong with loading environment variables into your app. So typically when you work with environment variables, you also want to make sure that they are loaded properly into your app. And you can do that with Zod as well. And I'll show you an example of all of them in a second. Right, so here this is also something we can run through Zod first. And environment variables, you can load them anywhere here. So in these API route handlers, in server actions, as well as server components. And for the other ones, by the way, so a webhook will not get submitted to your server component or server action. So a webhook will only get submitted to your route handlers, and the same for a third-party API. All right, so what next? Where else is a backend gonna get external data from? Well, maybe you're reading data from your file system, right? Maybe you're loading some file or data in a file into your application, right? The file system is an external system, and there are things that can go wrong there. We can run that through Zod. So what else can we get data from on the back end? Well, we can also read data from the URL. So on the back end, the same as on the front end actually. So we can actually just copy this. I can copy everything here because it actually works almost the same on the back end. So here I also want to run it through Zod. Now typically you're also going to have a database, and typically these databases are a separate server. So you would have a separate server here for a database. Let's say we have some Postgres database, and here on the back end we may be getting data from that database, right? So here is another flow of data into our backend. Now typically you use an ORM for this. So typically there is an ORM in between here. So that could be something like Prisma or Drizzle, or if you're using MongoDB, it will be Mongoose, for example, and they are sitting in between your backend and the actual database server. And getting data from a database, you can do that in all of them. So you can even fetch data from your database in your React components these days, as long as they are server components. And all of them can also interact with the file system, and they can also all deal with the URL. So let's quickly go through them and see an example of them. So very commonly, we're going to get API requests from the front end, and this will be very similar for all of these three, right? So these are all network requests that may have some data for us. So we want to run that through Zod. So here on the left side, let's say we have some API route handler that will receive a post request so that the front end can submit something. Let's say the form that we were talking about before. So here's where we're going to receive that form data. So here we're in a route handler and it's going to receive some data here. So here, let's see, we will get a request and we want to see the body of that request. So we can parse that body. We can take the request and convert it from JSON into normal JavaScript object. And this body is now going to be type any. That's the default in TypeScript. A better type here would be unknown, as we've seen, because we don't really know what it's going to be. So we want to restrict ourselves before we try to access anything. For example, maybe we expect the body to have some kind of body.address. Maybe we expect there to be an address property on the body. And when you type it in TypeScript as unknown, TypeScript will warn you that we don't know what it's going to be. So you cannot just access that here, right? So as we've seen, to prevent that, we would have to make all of these if statements and then also verify that if they exist, they are of the right type. And you could go down that route, but it becomes very messy. It's not really a structured way of validating that something exists and that it is of the type that you want it or expect it to be. So this is again a place where we want to run it through Zod. Now, as we mentioned before, since we are going to do the same validation as on the front end, here is probably where you want to reuse a schema. You don't want to repeat yourself by defining another schema here. So here is where you would import a schema that you have already used somewhere else. So what you can do is you can create a library folder, and in there you can create a file where you're going to keep all of your schemas. So you could call it validations.ts, and maybe you also want to have a file for your TypeScript types. And then here in validations is where you would have the schemas that you want to reuse. So we could have, for example, if we want to export that, a checkout form schema, and that's going to be an object, and that could have a bunch of things in here. Let's see if Copilot can suggest some interesting things. Well, actually I get a name here, and you can see how fine-grained we can get with Zod. So we can say minimum, custom error message, a maximum, custom error message, and even optional. And we can even say an email, a phone number, right? That's also very helpful, an address. Right? And again, imagine you had to do all of this with a bunch of if statements. So you would have to check if the string is an email. Does it have a certain length? Is the phone number a certain length? And if there's anything wrong with them, we would have to create a custom error message. Right? It would be so messy to do ourselves. So Zod is actually just a very ergonomic way of doing this. Right? Maybe payment method. some enum, and let's say that this is how we expect our checkout form to be shaped. Now we can import that on the front end and use it to validate the incoming form data. And now we can also import that here on our back end. So we can say parsed form is going to be checkout form schema, which we can import from our validations file, and we can do save parse and just run the body through there. And if that's not the right shape, we want to return a next response. Let's say we'll send back some JSON. We can send back the errors, right? So Zod will give us nicely shaped errors, and we can change the error format, and we can also send back a status code of, let's say, 422, which means the client submitted malformed data. And otherwise, if it was successful, we can continue here with this data, maybe store it in a database or process it further and return some success response perhaps. And the nice thing here is, let's say we want to change the shape of the checkout form. Since we're using it on both the client as well as here on the server, you may expect there to be issues. But here we won't have issues because we have centralized this in one place. We have one source of truth. So if we change something here, maybe the name should be at most 25. Now immediately on the front end as well as on the back end is the validation updated. And also if we derive a TypeScript type from this, right, so maybe we do need a type in our application. So then here in our types file, we could say z.inver, and here we need to pass type of, and then it's the checkout form schema, which we can just import in this file. And then we have a checkout form type, which we can then export from here, right? And now if we make a change here, or let's say we want to remove the cache option here from payment methods, I can update it here, and now it's immediately synchronized with both front end as well as back end, and synchronized with our TypeScript type, right? So it's really nice to have one source of truth, right? So this was an example of how to parse incoming network requests on the back end. Since we control the front end and back end ourselves, we can use something like TRPC to make it really robust, or you can just use Zod like what we've done here. Now, if you're getting incoming data from a third-party API, we don't control that side of things, so we cannot use TRPC there. So here is where we should actually use something like Zod. And if you have incoming webhooks, it's the same story as with third-party API. We do not control that side of the equation, so here we want to use Zod to validate the incoming payload. So with webhooks, if Stripe sends you a webhook, you do want to verify that the incoming webhook is actually coming from Stripe. So in this example, we were submitting form data from the front end to our API route handler. Now these days, you can also submit data with server actions, but fundamentally nothing has changed here, so you still can't trust what you get from the client. So also in a server action, you would validate the data, and you don't submit data to a server component, so that's not relevant here. All right, so then let's see what else we have. We also have environment variables. So a lot of things can go wrong with environment variables. So one approach you can take here is to create a simple TypeScript file. Let's call that env.ts. And here you can actually just create a schema for what you expect the environment variables to be. So we can say z.object. It's an object because what we're going to validate is the process.env, right? So in a Node.js environment, you're going to get process.env, which will be an object with all the environment variables, right? So we want to validate this variable. So that's going to be an object, and this may have things like database URL, and we want this to be a string. Now, maybe importantly, we expect this to be a non-empty string. So this should be at least 1 characters. You can have things like a port. A port may actually be a number, and we have maybe some third-party API key, also a string with a minimum of 1, right? And then we can say parsed env, and we can take that schema and we can say run that process.env through that schema. And now this could be a good use case for the parse method, because if there is something wrong, we actually may want to throw an error and we can immediately fix it as developers. So instead of using save parse, you may want to consider using the parse method here. And then we get the parsed environment variables here, which we can export here. So then if you want to use environment variables somewhere else, and that can be anywhere in the route handler, server action, server components, let's say in some route handler here, let's say we want to use one of those environment variables. Instead of using process.env, we can use this exported variable parsed env. We can import that from there, and then we even get autocomplete here, so we can see which ones we have. So database URL and third-party API key. That autocomplete is not what we get with process.env, right? So if I use process.env, I don't get autocomplete here. I can't see database URL here, but we do get that here. And now we also know that it has been loaded properly, right? So that's not a good use case for Zod. All right, so then let's take a look at file system. So we could also have, let's say, JSON data in our local file system. So maybe in our library, we have some JSON here. Let's call it data.json. one, and that's just going to be some data like this, right? And maybe we want to get access to this somewhere, and that can happen in any of these, right? So let's say it's in our route handler again, and so now here, let's say we want to get that data instead of hard coding our product here, we may want to get that data from that JSON file, and that would look something like this. So here we would get the JSON directory. I will import the path module, and then we can read the file content there with fs.read file, and we need to import the promises version from the file system module. So then we get the file contents, but again, we don't know for sure whether that's the shape that we expect it to be. So then we can run this through some product schema that we may have, which will just make sure that it has this ID, name, and price, and it also has, and also, for example, whether price is a number, right? So we would create a product schema like we've done before, and then we can be rest assured that what we got from the file system is indeed the shape that we expect it to be. All right, so let's take a look at the URL next. So also on the server, we can read data from the URL. So let's say we have a server component. So this is a server component, and server components get access to also the search params. So we can say search params, and here we get it as props. So before, here on the front end, we got it through the use search params hook, but here we get it through props, and so we can read data from the URL in a server component. And Next.js does give us a type for this. So here we can type the props, and then we can say search params should not be any, but search params itself is an object, and Next.js gives us this type. So it's going to be an object, and then each key is going to be some string, and the value for each key is going to be string or an array of strings or undefined. But when we read data from a URL, we want to make sure that it has a particular shape. So for example, we can say search params schema. We want to make sure that what we get is some object with an ID, let's say. And here, what we can do is we can coerce it to be a number again, because everything you get from a URL is going to be a string. So here with an ID, for example, we maybe want to transform it to a number, and also color that it's only going to be red, green, or blue. These search params, we can run it through our schema. So we take search param schema, save parse, pass in whatever we want to validate, and then this is what we get back. And this is then what you want to use, right? So any further processing, this is a typical mistake. People sometimes make the mistake of then using search params. This is not validated, right? This is unsafe. It's this variable now that we get back from Zod that we want to use. And Zod will give us a data property with all the data. So it will have an ID and color in the success case. Or if there's an error, Zod will give us that in .error. All right, so then let's take a look at the last one. And this is actually a major one because we often get data from a database, of course, in our backend. And we can get data from our database in route handlers, in server actions, as well as server components. So let's say we have some product page here. This is a server component. So these days what we can do is we can fetch data here from the server, right, in a server component. So here I'm using, let's say, Prisma as an ORM, and here we attempt to find some product where the ID is 1, and then here we get data product. When I hover this, you can see this is actually typed as something. So Prisma does type this. So do we still want to validate data that we get from our own database? Well, here I would say it's a little bit less necessary because Prisma is essentially acting as an intermediary here. So with Prisma, we are also creating a schema in which we describe what the data needs to be. So for example, for a product here, we will say that it needs to have an ID, name, and price. And so if we ever try to insert something in the product table that's not of this particular shape, Prisma will prevent us from doing that. And also when we get back data from this table, Prisma will essentially guarantee that it's going to be of this shape. So then do we really need to parse this whenever we get back from Prisma here? Well, technically, of course, it's always possible that what you actually get back over the wire is something different than what you would expect. So to really exclude any edge case, you may want to run this through a Zod schema as well. And I would say, especially if you're doing raw SQL queries, is where you want to do validation. Because whatever you pass here, Prisma will transform this into a SQL query for you. And that's a little bit safer than doing it yourself. So if you're going to do it yourself with SQL queries, there's a higher degree that what you get back is different from what you expect. But if you're doing it this way with the Prisma APIs, you could make the argument that it's not necessary here. Now, that being said, it's possible that you're simply passing the wrong query here. So you make some mistake here, maybe some logical mistake here. So it's always possible that what you get back here is different from what you expect. So you may want to run it through a Zod schema as well. And now you could say, okay, so we're going to duplicate ourselves because we also create a schema with Prisma. So now we would also have to create a schema with Zod, right? Which is essentially going to be the same as here with Prisma. However, there are NPM packages that can take a Prisma schema and convert it to a Zod schema so that you're not repeating yourself. So then for any database related validation, you can make Prisma the one source of truth. And then if you do want to do that edge case validation with Zod, you can just use a package like Zod Prisma types, which will create those Zod schemas for you from the Prisma schema. All right, so that was a lot to take in. Now in my React and Next.js course, we also talk about this, and you will see in real world applications how to implement all of this. So check out the links in the description. I hope it was helpful. I hope you learned something. Thanks for watching, and I hope to see you the next one.